Welcome, welcome, my students. I am skipping ahead. I'm going to record decimals next, and then I'll go back and do 2a3, which is multiplying and dividing fractions, just in case you guys start running across decimals in, actually, I don't think you will in 1316 just yet, but still can't hurt. So the first thing we have is a decimal number is a fraction whose denominator is a power of 10, like deciliters, decimal, 10. So we have to use place values for this. This is the thing that makes our numbering system the shit, but it requires zeros. So this is what makes it different from the Roman numeral system, but the Roman numeral system is kind of ridiculous because you just keep I. So to the left of the decimal point, we have the ones, tens, hundreds, thousands, 10,000ths, and these are actually, oops, that's a 0. Powers of 10. And you can actually use the powers of 10 to decompose numbers, which is something they actually teach now in elementary school. I don't think they did when I was a kid. And then if you look over here on the bottom, we're getting the same powers of 10 going the other way. And only like the middle point is this ones place, 10 to the 0, anything to the 0 power is 1. So this one is 1 over 10 to the first. And 1 over 10 squared. And they keep going like that. So because the upper counting whole numbers are in powers of 10, the fractions had to be in powers of 10 in the decimal notation. Now we know we can use any denominators we want for fractions, but to get in a straightforward decimal conversion, we use base 10 fractions. All right, so first we're going to talk about our place value. The other thing to notice here is that our first decimal position is called tenths, not oneths. There is no 1 over 10 to the 0 because that would still be 1, which is the ones place. So we have tens, ones, and then tenths. So every once in a while I get a student who will, it's just like a word salad kind of thing. You're not doing it deliberately, but we're going to identify the words. So here we have 10th, 100th, 1000th, 10,000th. That is the 10,000th place. And then here we have 394, and that is 5/10. The one they underlined is tenths. All right, so this is 10,000ths. And this one is 10ths. All right, what do we get here? We got 3, so 10th, 100th, 1000th. 1000ths. And then 10th, 100ths. 100ths. We'll extra emphasize it. And we could also write the fraction as well. Now, for these decimals that end, that last position is also what would be on the bottom of the fraction to represent that. Like the 0.8351, that last digit is 10,000ths. So this as a fraction is 8,351 over 10,000. I tend to put like triple zeros kind of chained together like that. And then we could see if that reduces any. I don't know if it will, but it could. So regardless of what the place is, you can represent any decimal that stops by just putting it over whatever that place value is. And the reverse is true. If this is the fraction form, then I can take the fraction and go to the decimal form. But my bottom has to be a power of 10. And I have to be careful about whether the top is bigger or smaller than the bottom. Because here there were no zeros in the number, but down here it's going to get a little weird on some of them. And they put negatives for no good reason. But that's fine. We can handle negatives. All right, so this first one is 21 thousandths. So when I'm going to do these, there's nothing bigger. It's not like 1 and 21 thousandths. So we can put that 0 and then our decimal place. And then I'm going to go tenths, hundredths, thousandths. And now we fill it in starting with the digit on the right in the rightmost position, the one that we're using as the name. So since this is thousandths, the 1 goes here, the 2 goes there, and then because we don't have another number, I can always write 21 as 021, because for the decimal, I need that 0 as a placeholder, so it doesn't look like 21 hundredths, it looks like 21 thousandths. All right, so on 6 here, it's negative, so we're going to start with that negative, and otherwise it has no bearing on this. Again, it's not bigger than a whole, so it is 0 point. And then I have 45 hundredths. So let's start with 10th hundredth. All right, so 2 places and we got 2 digits. Cool. So the 5 on the end in the hundredths, and then the 4 just before it in the tenths. And there are no other empty spaces, so that is the decimal. Negative 0.45, or negative 0.45 hundredths, or just negative 45 hundredths. Yes. Words, yuck. And then last but not least, again, a negative. And 3/10. We got that 0 point. And there's only one place, and it has a 3. That's it. Terminates. None of these are repeating decimals. They're all what we call terminal, or they stop decimals. Okay. So that's taking our fractions and going to decimals, at least when the fractions are less than 1 whole. So we haven't actually seen, like I could have written this as like 34,021 over 1,000, and then I would have 34 thousands. So it would be 34 in front. It gets weird. But usually that's the first thing when you're doing a conversion, is to you separate the wholes from the decimal or the fraction. And that's what we're going to look at here. Yeah. A fractional part of a whole may be written as a fraction or as a decimal. The procedure below provides the steps to follow when converting a decimal to a mixed number or proper fraction. So mixed numbers, the wholes go out front, and then the resulting fraction is always proper because you've pulled out every whole, so the top number is now smaller than the bottom. So the digits to the right of the decimal point are written as the numerator of the fraction, just like we did before with the 8351. The place value of the digit farthest to the right of the decimal point determines the denominator. So like I was saying, the name we call it, that's what the denominator is going to be. The whole number part of the number is left unchanged. So we just write it in front of the fraction. Or you can write it plus the fraction, assuming there's no negative sign being weird. Once the number is converted to a fraction or mixed number, simplify the fraction to lowest terms if possible. So this is a huge, convoluted drama ball. I personally don't care which way you write the answer. I care about you guys getting to the answer and being able to tell me what the answer means. But I am not your only teacher. It is always fair game to ask how a teacher wants an answer presented. Generally, if it's a word problem, you should write your answer in a way that makes sense. So we wouldn't say, I'm going to eat 10/7 of a pie. we would say I'm going to eat a whole pie and 3/7 of another pie, or 1 3/7 pies. That's just how we talk colloquially. But saying I'm going to eat 10/7 of a pie is not incorrect. It just sounds a little funny from the English talking perspective. But I find it is always fair game to ask a question when you are not sure about something. The worst that happens is she won't answer the question. Most of the time, though, if you ask it, most teachers, sometimes even their non-answer will be an answer. So you got to get a little creative in deciphering the answers, but write each decimal mixed number or proper fraction, simplify. All right, so number 8 here, we have -7 and 41/100ths. Alrighty. So we start with the whole number part is still -7. And then next to that, we put our fraction. So like I said, tenths, hundredths. So we're going to put the 100 on the bottom and the 41 on top. So you can always think of mixed numbers as the sum of the whole and that proper fraction. The catch is when you have a negative, it's really those two things are negative. So you would actually think of it as the negative of 7 and 41/100ths if you wanted. Because there's not a good way to type 7 and 41/100ths in the calculator. Like sometimes if you just shove the number in front of the fraction, it may not interpret it as a mixed number. It might think you're multiplying, or it might just say syntax. So sometimes to type that in, you have to do something like this. I need the negative outside to say this whole thing will be negative after I merge them together. This is why I personally prefer improper fractions, because I don't have this, do I put a plus here? Do I put a minus here? This is confusing. What the heck's going on? It's one thing and it has a negative in front, or it doesn't. But I'm weird, so I really don't like the way mixed numbers look. Like it only makes sense when you're answering a problem, but mathematically, nobody likes them. They are too weird to read. All right, so this one is 10 wholes. So a 10 out front, and then that 517 on top, 10th, 100th, 1000th. So we put 1000 on the bottom. Now I didn't check before, but 41 I'm pretty sure is prime, so that's not going to reduce. 517 though, well, it's not divisible by 3. It's not even. And 7 doesn't go into 100 or 1000. And there's no 5s and no 2s, so there will be no common numbers. Cool. Because 10, 100, 1000, they're all just 2s and 5s. So those are the only numbers you actually have to check for reduction. All right, and we have -842.1, or 842 and 1/10. And then right next to it, 1/10. So 1 on top, that one is definitely not reducing. All right, so far it's just one over the other. Now we're going to start to see some reducing though. Because see, that was the last step. Simplify the fraction to lowest terms if possible. So I kind of hand waved it on the first 3. I talked through why they're not going to reduce. And again, you could convert this and then type the just fraction part on the calculator and then see if the calculator reduces it. And you can actually figure out what the reduction was just by taking the smaller number, dividing it into the larger number, like the numbers on top, to figure out what they divided out, what number. All right, so let's take a look here at our 2 and 2.15. So 2 wholes and 15 10/100ths. So 15 is 3 times 5. So the 3 won't go into 100, but the 5 will. So 100 or $1, if I split it into 5 equal parts, I would have 20 cents. So that is what 100 divided by 5 is, 20. 15 divided by 5 will be 3. So we are going to end up with 3/20. Now, sometimes when I'm doing this reduction, okay, here, I'm going to write like the way the book would want me to write it. So we would have 2, 3 times 5 on top, and 20 times 5 on the bottom. And then we would cancel the 5s. And then our final answer would be 2 3/20. Sometimes, though, what I will do is I might notate it as divide by 5 and divide by 5. So 15 divided by 5 would be 3. 100 divided by 5 would be 20. Then I just put the 2 back in front. I'm telling you this in case I write it like that on a problem. This is a shorthand for all of that. And then when you get really comfortable with your numbers, what you actually, a lot of people do is they'll just put slashes through the 2 numbers and then write what the smaller numbers would be like next to it as scratch work. So if you are very comfortable with your numbers, I'm not going to tell you, no, you can't do that, but you need to be very comfortable with your numbers. All right. So now we have 0.0592 tenth, 100,000, 10,000. Good Lord, that's huge. So 1, 0, and then oh. And on top is 592. All right. I know there's no 5s coming out of there, but there are quite a few 2s in 10,000. So let's take out the first 2, and then we're going to kind of hope that the result is odd so we don't have to do any more. No, it won't be because 92 is divisible by 4, so the top is actually divisible by 4, but we'll do it 2 twice. All right, so 2 into 5 goes twice. 19 would be 18, 9. 12 would be 6. So we have 296, and instead of 10,000, it is 5,000. Another 2. So that would be 140, because it's a 9. It would be 16, so 144 over 2,500. Oh, good Lord. Huh. 144 is 12 times 12, which is another 4 and another 4. 2,500 is 25 times 100, which is 25. Yeah. It's 25 times 25 times 4. So there's a single 4 in the bottom and a single 4 in the top that can come out of them both. So now I'm going to be dividing by 4. And what you can do is you can just 144 divided by 4 is 36. And then 2,500 divided by 4 is 625. Because I do way too much mental math. 625 is now a crap ton of 5s. It's like 5 times 5 is 25, times 5 is 125, times 5 is 625. So it's 4 5s being multiplied. 5 to the 4th. And the top is 36. It's all 2s and 3s now. No 5s. So that is our most reduced fraction. Again, though, if you just typed 592 divided by 10000, most of your calculators are just 36 over 625. And then if you wanted to show work, you could say, all right, what's 592 divided by 36? And it would tell you it is 16, because we did divide by 2, and then divide by 4. 2 times 2 times 4 is 16. Yeah. So if we do 592 divided by 16, we get 36. If we do 10,000 divided by 16, we get 625. All right. Now the next ones aren't so bad. They're smaller. So -23 and 10th hundred thousandths. You know what? Let me change the color. And 35 on top. So that is 5 times 7. The 7 will not go into 1,000. The 5 will, though. So 1,000 is like $10. If I'm going to split $10 into 5 equal groups, I'll have $2 for each group. So $2 would be 200 cents. So 200 on the bottom and 7 on top. So I'm going to put that down here. -23, and now it is 7 over 2. That is a horrible 2. 200. All right, last one, -18.6. Start with the -18, and then that is single digit, so it is tenths, 6/10. Those are both very even. So -18 stays the same. 6 and the 10 are both divisible by 2, so we will now have 3/5. That is our last one. So a lot of reduction. Again, if you have one of the nicer calculators, it will do the reduction for you and it'll show the answer as a fraction. Almost all of them do that now. Oh man, I remember when calculators started to do fractions. Oh, it was awesome. And then I remember they took the calculators away. Not awesome. I still don't have a good explanation for why that was the way to go. Okay. Now this is an interesting one. Students who had already passed college algebra, they're in my elementary math methods course, so they're going to be future teachers. And about half of them couldn't do this. I asked a very similar problem in figuring out where do these decimals go. So this is not as straightforward as you would think. So we know how to sort whole numbers. We can also sort decimals, but we have to make sure we're comparing apples to apples and oranges to oranges and not apples to oranges, meaning it is difficult to compare tenths to hundredths. One of them will have 1 digit, the other will have 2 digits. So it's like saying, which is bigger, 5/10 or 20 hundredths, 23 hundredths there. I can't compare those. The bottoms are not the same. But I could take 5/10 and multiply it by 10 over 10, so it would be 50 hundredths. And now 50 copies of a 100th piece or 23 copies of a 100th piece. Now I'm talking about the same bottom number. I can just look at which one's bigger on top. So when we're trying to figure out numbers in between, we are going to need to make sure our denominators are the same on all of them in order to make comparisons. All right, so the first one, which number is between 68.54 and 68.56? Well, 68.55 is definitely between those. The front number is the same, and if you notice, all of them, the front number is the same. So really, we're just trying to figure out which of these decimals is in between 0.54 and 0.56. 0.55, though, is the 54, 55, 56. Yes, that one for sure is in between. But then we get to 0.549. And some people would say, well, that's just 54, and this is 549. That has to be bigger. But 549 is also bigger than 56. These are not the same fractions. So in order to make the comparison now, that's 68.54. To figure out what the equivalent decimals are is we're going to put some zeros on the end, because putting an extra 0 here after the decimal place doesn't change the place value. I can call that 54 hundredths. I can also call it 540 thousandths. What I've done is multiplied the top of the fraction by 10, and I've changed the place value 1, which is multiplying the bottom by 10. So I can put trailing zeros on a decimal. All right, so 540 thousandths to compare with these next two. And then the other one would be 68 and 560 thousandths. So is 549 between 540 and 560? Yes. Is 496 in between 540 and 560? No. All right, so if we're doing the circle, those two are good. And then this one, 68.5501. So that's 5,501 ten thousandths. These guys are still tenths, hundredths, thousandths, not 10 thousandths. So now, same number of digits, 4 places after the decimal, 4 places after the decimal, 4 places after the decimal. So we have 5,400 and 5,600 is 55 and 1, 5,501 in between 5,400 and 5,600. Yes. So this is also in between. So when you are looking at your decimals and you're trying to figure out which one is bigger or smaller, to compare them visually, you need to make sure they have the same number of decimal places. Now, if the numbers before the decimal are off, it doesn't matter what the decimals are. 18 will always be bigger than 16 if that's what the front numbers are. So you start from the left until you find a difference. And if that difference is a missing number, you put a 0. All right, I'm going to pause it and then we will come back to rounding practice.